Uh-oh. Can you hear me?
Yes, sir.
Good, thank you. And how lovely, okay. Got to do this when I got here this morning. There we go. And as with every morning, where did we leave off? Chapter 7, right? We were just going to start trig identities, if I remember correctly. Yeah. My in-class attendance is not. Let me see. Yeah. Thank you for putting your names in the whatever. I think my people who usually show up to class are in Zoom. And you can't see me because the stupid thing isn't seeing the camera. Oh, this is freaking delightful. I reported this last Wednesday that this was going on, or last Thursday, that the camera is not being recognized by the computer. And it's not doing it. Okay, so I'm not going to fight it. But what I am going to have to do again is use my webcam. Which, as you all know, is not the greatest. And I left my other cord that I would attach to this. In another room. as we know, the camera on the computer is worse than using my camera. Well, I got someone in the classroom, yay! Okay. I was expecting to have a high absentee rate today simply because it's Columbus Day. And a lot of public schools, Columbus Day is a work day for teachers. Today's the 11th, yes. It's my eldest, his birthday is today. He calls me old man, I call him old son. So, yeah, he's 40. 40? At least today we won't have that, well, we have a little bit of it right here. That where it's reflecting the projector. But we're good. All right, next thing I need to do is get out the handy dandy loop. Presenter widget. I don't know what it's called. Just use it. Does what I want. This thing makes the slides change. Oh, come on. I know the problem. Ha. Bingo. All right. We're going to use algebra to simplify geometric expressions and establish identities. I need okay. Did we cover this in class? You don't remember? I always look to the camera there, so I better start looking here. Two functions f and g are identically equal if they equal each other. No duh. But this just gives us a definition of identically equal. It also means that they are equivalent. That means whatever I put in for x for f, and I put it in for x in g, I'll get the same result. That's what it means. Okay. And that's what this is saying. Provided x is in the domain of both f and g. F and g. Sounds like I'm cussing. Okay. Such an equation is referred to as identity, right? Because this side is the same as that side. 80 equals 80. Right? If they both work out that they equal 8, then it's the same number. So that's why it's called identity. An equation that is not identity is called a conditional equation. I remember talking about this. Conditional equations, what you dealt with all through algebras. 3x plus 9 equals 27. That's a conditional statement, a conditional equation. it's conditional because it depends upon what value of X you put in to make it a true statement, to make it identity. Quadratic equations are conditional, and you can have up to 2 numbers that make it a true statement. So that's what they mean there by that. Here we have, yeah, we've done this. The quotient identities and the reciprocal identities. These you should already have in your head. The reciprocal identities and the quotient identities. All right. This is y over x, x over y, 1 over y, 1 over x, x over y. Reciprocals. Where sine is the y value, so 1 over y is the cosecant. Cosine is the x value, so the cosine is the x value, and so secant is 1 over x. And cotangent is just the reciprocal of tangent. Which is what it says right. Even though there's using that. Okay. Pythagorean identities. I think I've gone through this. I know I have. Now, if you start with this one and then just divide by sine, you'll get the second one here. And if you divide, sine squared, and if you divide 2 by cosine squared, you'll get this one. So these identities will show up, but they'll show up in different ways. Okay. So like, sometimes you'll see it as 1 minus cosine squared. That's just subtracting cosine from both sides. It's still a Pythagorean identity. I can rewrite sine squared as this. Or I can write cosine squared as 1 minus sine squared. There. I can write 1 as secant squared minus tangent, or cosecant squared minus cotangent. Or I could say tangent equals secant squared minus 1. So they can show up in different ways, but they'll still show up. Even in odd identities, we already discussed that sine and cosecant, tangent and cotangent are odd functions. That means if you take the sine of the negative angle, it's the same as the sine of the positive of that angle. Same thing is true with cosecant, tangent, and cotangent. With cosine and secant, if you take the cosine of a negative angle, it's the same as the cosine of the positive of that angle. So the cosine of pi over 4 is the same as the cosine of negative pi. Because if you look at the unit circle, the negative angles, sine and cosine, are on the same side of the y-axis. So that means the cosine is always positive over here. So if you go a negative direction, go in a negative direction, and then go the positive direction, you're going to be in the same quadrant. You're going to be in the quadrants you're in. The cosine will have the same sign. So in the first and fourth quadrant, cosine has the same sign, and in the second and third quadrants, cosine has the same sign. They're both negative over here, and they're both positive over here. So that's how that works out. Okay. And 4 basic algebraic techniques are used in establish identities. Rewriting a trigonometric expression in terms of sine and cosine only. That is extremely helpful. Okay. Because if you just have just two trig functions to worry about, then it makes it a lot easier to deal with. Sometimes that's not possible. Multiplying numerator by a ratio of a well-chosen one. What do I mean by well-chosen one? Well, that's what I've been saying all along. We're always multiplying by one. It just depends on what version of one we're using. Right? So like when you're dealing with fractions, adding 3/5 to 7/8, well, I need the denominators to be the same. So we're going to choose a 1 to multiply 3/5 by. Well, that's 8/8. This is 1. It's a well-chosen one for this fraction. And for this fraction, it's going to be 5/5. Because multiplying by 1 doesn't change what it is, it just changes what it looks like. So we get, what is that? 24/40 plus 35/40, which is what? 59/40? Because once the denominators are the same, all the action happens in the numerator. And if I remember correctly, I think 59 is a prime number, so this does not reduce. Yeah, it doesn't reduce. 3 and 9 are factors. 7 doesn't divide it. Okay, writing sums of trig ratios as a single ratio. So that means you're going to end up multiplying by a well-chosen one, so that the denominator is the same, and so you can combine the numerators appropriately, and then do factoring or whatever is necessary. Sometimes you can use identities to start changing. Okay, simplify by rewrite tangent theta over secant theta. Now, did we do this in here? Because I remember doing these slides. It may be in a different class. Does anybody online in Zoom remember doing these? Because I remember doing them, I just don't remember what class it was in. It could have been my Tuesday, Thursday class.
Yes, we did them.
Okay, thank you. Show that these are equal. Simplify by factoring. Yeah, this is where we factor tangent out of here, and we factor this as the difference of two squares. And then I would multiply this one up by sine u, by cosine u over cosine u. Multiply this one by sine u over sine u. And then do combining like terms and factoring. And I think if I remember correctly, this worked out to be just sine. Anyway. So we write it as sine and cosine. Tangent is sine over cosine, and secant is 1 over cosine. 1 over cosine, you're dividing by a fraction, so you're going to multiply by its reciprocal. And that just becomes sine. And this one multiply by we're going to multiply by something down here to make this a trig identity. Because when you multiply the sum and difference of the same two terms, you get the difference of a difference of two squares. So your denominator becomes 1 minus cosine squared. Well, 1 minus cosine squared is just sine squared. And so we simplify that. And we get 1 plus cosine theta over sine theta. Okay, factoring it, all right, so this is going this direction. And this one here is going back to this. Because then we have the difference of 2 squares, so it's going to be you're going to take the square root and it's of each term. And it's going to be the sum of those 2 square roots times the difference of those 2 square roots. And in fact, I'm tangent out of both of these. The cosine theta plus 1 goes away because they factor out to 1. And that just leaves us cosine minus 1 over tan. And this one, yeah, to get the same, and I already discussed that a little bit. And if I remember correctly, what did we do here? After we did that multiply, cosine. Oh, these two are the same, and I think they went to the trouble of related. And so we can, and then we have, and then cotangent u is cosine over sine. And so this just becomes cosine plus cosine, which is 2 cosine. And when one of these cosines go away with this cosine, actually just those cosines go away, so it's going to be 2 over sine u, which is 2 times cosecant. That's not, I would end up writing it as 2 times cosecant. But that's me. So we did this one as well. I'm going to rewrite cosecant as sine, 1 over sine, and you'll write tangent as sine over cosine, because then the sines will go to 1, and it'll leave me 1 over cosine. And now we're just going to have 1 over cosine, which is c. And there we have it. So the right side is going to read, so it's the right. So here we have I remember that they did it differently than I did it. But let's see. Okay, what they did, they rewrote these. This sine squared of negative theta is sine of negative theta being squared, and cosine squared of negative theta is cosine of negative theta being squared. So they just rewrote it, stating saying exactly what this square means. You're going to take sine of this number and then square it. Well, sine of a negative is the negative of the positive. And then cosine of negative is just cosine of positive. And then when you square a negative, you get a positive. And so this is just trig identity. Pythagorean identity. And so it just equals 1, which is what they say up there. So I would factor the numerator. I wouldn't worry about the signs yet. I'd factor the numerator. I still factor this. that. And notice down here, they factored a negative sign out of these two to make it this. And then these two go away. And that makes this negative. So we're gonna end up with cosine minus sine. Because we're left with a -1 down here. And dividing by -1 changes our signs up here. And so this becomes a negative sine theta plus cosine theta. And we typically would write this with a minus sign in the middle and a positive out. Remember that. Why? Write everything in sine and cosine and see what happens. I'm doing it that way. And so if I multiply so I write this as a single fraction, so I'm gonna add tangent over tangent. And which gives me tangent plus 1 over tangent. And dividing by a fraction is multiplying by its reciprocal, which is what they did. They didn't show the step, but you're gonna be multiplying the numerator up here by this denominator. And this numerator just stays as the denominator. And 1 plus tangent is the same as tangent plus 1, so those go away. So it leaves us with tangent. And multiply the first fraction by sine over sine, and the second fraction by, well, would I do that? Yeah. By 1 plus cosine over 1 plus cosine. We multiply this out, but 1 plus cosine times 1 plus cosine is 1 plus cosine squared. And then sine times sine is sine squared. I can do away with these, no, I have to square it now. And I would write it as two binomials being multiplied and use the binomial multiplication to get this right here. And now at this point, they rewrote it so the sine squared and the cosine are next to each other, but that's just sine squared plus cosine squared, which is 1. Right? So they just wrote it this way. They rewrote it, but it's not necessary. So this is 1 plus 1, which is 2, so this becomes 2 times cosine theta. Well, 2 times cosine theta, I can factor 2 out of that and get 2 times 1 plus cosine theta. And those two go away because they equal 1. And that just leaves me 1 over sine, which is, 2 over sine, which is 2 times cosine. Okay. I would try first by writing everything in sine and cosine, and that's exactly what they did. The common denominator is cosine sine. At this point, I would multiply each term by the common denominator. I'd multiply the numerator by cosine sine, and I multiply each term up here by cosine times sine. Those are V's. So this one gets multiplied by the same thing. Cosine. Sine. These. So here these signs go away. These cosines go away. This goes away with that because they equal 1. My denominator is just 1. So in the numerator, I have sine times sine, which is sine squared, and cosine times cosine, which is cosine squared. So I wind up with so you have 1 in the numerator. In the numerator, this is a fraction from the numerator. And this is a fraction from the denominator. They just flipped it and did the multiply. Now the cosines go away, and the cosine sign goes away because they equal 1. So this whole thing just equals 1, which is what we were trying to prove. They do the same things I do. They just show it a little differently. Thanks a lot. I multiplied the left-hand side by sine plus 1 plus sine, numerator and denominator. Which is what they did. They multiplied numerator and denominator on the left-hand side by 1 plus sine theta over 1 plus sine theta. The numerator gives us 1 minus cosine squared. And we just leave the denominator as a multiply. We don't multiply it in because we want to factor because we might be able to reduce the fraction. Well, 1 minus sine squared is just cosine squared. And so this cosine goes away with one of those cosines. And so that's just going to be cosine theta over 1 plus sine theta, which is what we have. I don't know why they said cancel. I have no clue. Anyway, it's almost always preferable to start with a sign containing a little more complicated, rewrite the sums or differences of the quotients as a single quotient. Sometimes it helps to rewrite one side in terms of sine and cosine only. Always keep the goal in mind. You're always looking to see what you want to go away and what you want to keep. And keep in mind the form of the expression on the other side. That could make some difference. Sum and difference formulas. Oh, this is where we left off. Yes, this is where we left off, right? Cosine of A plus B, cosine of alpha plus beta is the Greek letter alpha, the Greek letter beta. Cosine is quite simple from my point of view. It's going to be cosine minus sine, or cosine plus sine. The sign between the two multiplies is opposite of the sign inside the angle parenthesis. Sometimes I've seen this written this way in textbooks, which can be very confusing if you're not paying attention, which happened to me when I first saw it. Cosine of alpha plus or minus beta equals cosine alpha times cosine beta minus or plus sine alpha sine beta, where they would put the plus or minus, but here they put minus over plus. So the plus goes with the minus and the minus goes with the plus. The sign is simpler in that whatever the sign is between here is the same as the sign over here. But the complication comes in what's being multiplied. Questions on this? Right here. I like this, the notation that I just showed you, because it simplifies it into just one statement rather than two statements. Okay. All right, this is why we have the sign. We have the add and subtraction. I know what the cosine of 60 is. I know what the cosine of 45 is. So I know that 60 plus 45 equals 105. So I can rewrite the cosine of 105, sorry, as the cosine of 60 degrees plus 45 degrees. And so I use the trig identity. I use this, I use the sum and difference formula. And so we do the cosine of 45 times the cosine of 60 minus the sine of 45 times the sine of 60. The cosine, the product of the cosine of both angles minus the sine. Whoops. And if I remember correctly, I cannot correct it. Oh, I can. And it will magically change on screen. There we go. So it won't change because as soon as I started typing there, it changed the slide. So I know the cosine. What's the cosine of 45? This is one of the ones you probably should, is from the first quadrant. And from the first quadrant, you should have all those residing in your head. And the cosine of 60, that's a nice one.
Square through.
Well, yeah, 45 is pi over 4. And so this cosine of pi over 4. And this is pi over 3. So the cosine of pi over 3. All right. The cosine of pi over 4, or 45 degrees, is square root of 2 over 2. And the sine is the same because that's how that angle works out. That's the square root of 3, square root of 2 over 2. And cosine of 60 is 1/2, and the sine of 60 is the square root of 3 over 2. Well, when I multiply here, I get the square root of 2 over 4 minus, and then when you have radicals of the same index, you can multiply what's underneath, and so that's going to be the square root of 6 divided by 2. So I write this as a single fraction, which is the square root of 2 minus the square root of 6 divided by 4. I cannot do do that subtraction in underneath the square root symbol. It just isn't possible. We can't do that. Here. Oh, they rewrote this and they factored out the fraction. I would leave it this way. Because that's a single number. This is a fraction times a number. I know it's merely a matter of semantics here. But isn't it easier to leave it this way rather than worrying about factoring out that 1/4? So this is the exact, see it says exact, that means you leave the square roots there. You don't type it into the calculator. You don't type in cosine of 105 because I want the exact value. When you type in cosine of 105, once you do that, you're going to get an approximation of this number. Not exact, because you have to round. And as soon as you have to round, it's no longer an exact value. So cosine of 5 pi over 12. Well, I know 5, I can rewrite 5 as 2 plus 3. Why do I want to choose 2 plus 3? Because 2 and 3 are factors of 12. So I can rewrite 5 pi over 12 as 2 pi plus 3 pi over 12, and then rewrite those as two separate fractions. 2 pi over 12 plus 3 pi over 12, and reduce the fractions. It's just a puzzle. They're fun. Okay, and so 2 over 12 is 1/6. So this is just pi over 6, and 3 over 12 reduces to 1/4. So this is just pi over 4. So now my, what is it, cosine? Cosine of 5 pi over 12 is the same thing as the cosine of pi over 6 plus pi over 4. And so now I have the sum, so that means I'm going to have the product of the cosines minus the product of the sines of these two angles. So it's going to be the cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. So sine of the cosine of pi over 4 and the sine of pi over 4 are both the square root of 2 over 2. And so the cosine of pi over 6, the cosine of 30 degrees, isn't that the square root of 3 over 2? And the sine of the same angle is 1/2. All right, think about your unit circle. And we're dealing with this angle here, pi over 6. And the coordinates on the unit circle is the square root of 3 over 2 and 1/2. So the x value is the cosine of pi over 6, and the y is the sine of pi over 6. So there we have that. And then again, we just multiply and simplify, so we get the square root of 6 over 4 minus the square root of 2 over 4, which is the square root of 6 minus the square root of 2 over it looks an awful like the other one, except they're subtracting in the opposite direction. So all it is a puzzle. To do these things is looking at how can I rewrite it so it means the same thing, but it looks different, so I can do this fancy.
Did he leave the call?
Because I didn't unmute myself. Can y'all hear me again? Yeah. Jocelyn, did you say something?
Yeah, I was gonna say we can hear you.
Okay, good. Thank you. All right. Yeah, and I see John and Julian's. It is Julian, it's not Julian, right?
I went to elementary school through high school with a guy named Julian. Of course, he was a white guy. Either way, okay, yeah. I bet you're used to it either way. Depends upon the ethnicity of the speaker, right? Yeah. I've been teaching in South Texas. I mean, I taught in Poteet and I taught in Pearsall. I taught at Southside. I taught over at East Central. That really doesn't count. I taught at Mark Twain. So, and my wife's mother's family came from the west side of San Antonio. Yeah, her grandmother was a member of La Trinidad United Methodist Church. I can't say it in Spanish. I need to learn Spanish. I've taught in predominantly Hispanic populations. So I tend to try and pronounce names correctly in Spanish. Anyway, I'll shut up now and get to the stupid thing that this computer doesn't want me to watch. Oh, what happened was the computer decided to do what it did the other day. It started to, it needed a restart, and probably I had some stuff it needed to update. And so it decided that this was the time to do it. And so now I have to find out where we're at. Come on. Holy crap. There we go. We did that already. Are we here? Nope. Past that. Thing is, the slides I'm looking at don't tell me what chapter we're in. I mean, where we're at. Oh, there we are. Pull up my Zoom, punch that button. And not only did the computer do a restart, but the freaking camera up here is dead. I mean, it's pointing in a bizarre direction and the lights are off. So I have no idea what's going on here. Okay. I have another camera. It's a presentation camera, so it's a better camera and it's a bigger camera. And I may bring that to school and just leave it here for days like this. Okay. And it looks like it's going to be an ongoing thing in this room. Okay. And so they did the same thing I did. I mean, they didn't explain factoring what they did to get. Oh, yeah, they did. They did it here. But they didn't show this work. Okay. They didn't show that pi over 2 plus pi over 3 is 5 pi over 12. And they just went straight from here to this one down here. They skipped this part. They implied it, they didn't. And then the rest of it we had done. And again, they factored out the 1/4. You do not need to factor out the 1/4. I think that's asking for incorrect answer. Right.
remember that sine and cosine are a phase shift from each other? Pi over 2 phase shift. And that's all this is. This is showing the phase shift between sine and cosine, and it's from sine to cosine. So if you can rewrite the angle, whatever angle you're given here, to look like this, you can rewrite it as sine of theta. And hopefully it'll be a nice angle. Or it'll be an angle that you can subdivide into 2 angles. No. The sine and cosine. The same thing with sine. It works the same way with both. And now here's the sum and difference formula for sine. Right? If you're adding alpha and beta, you're adding the products of the sine and cosine. And if you're subtracting alpha and beta, then you're subtracting the products. Now the trick is, since it's going to be sine times cosine, in both cases, it's keeping straight which one you're taking the sine of, which angle you're taking the sine of times the other angle. With addition of the 2 angles, it doesn't matter if you do sine alpha cosine beta first, or if you do the cosine alpha sine beta first. It's still, because that's just commutative property with the addition. But with subtraction, you don't have that luxury. So you have to keep it straight. So it's a good idea just to keep it straight in both cases. For both cases. It's the sine of alpha times the cosine of beta. Plus or minus, and this could be written as a simple one as well. With you could write this as sine of alpha plus or minus beta equals the sine of alpha times the cosine of beta plus or minus the cosine of alpha, the sine of beta. And what they've chosen to do is to keep the angles in the same order, just switch the sine and the cosine. So, and this is different than the way I was taught, where you kept the sine and the cosine the same, sine times cosine, and you switch the alpha and beta. But it all works out the same. Because the way I learned it was sine alpha cosine beta plus sine beta cosine alpha. So we're just using the commutative property on the second product. But for it kind of makes sense to keep the angles the same and then just switch the sine and cosine. Because you're going to do sine of alpha and sine of beta, and you're going to do cosine of beta and cosine of alpha, is just keeping it straight. Which one comes first and which one comes second? And which one comes first and which one comes second? Then writing it as a single identity, the plus goes with the plus, the minus goes with the minus, where with the cosine, the plus went with the minus. That's why we had minus over plus in the some are different to those products. Okay. Now, I know, and I know that, I want to get 1. So I want to subtract 2 factors of 12 that equals 1. So that's 4 minus 1, 4 minus 3. Because 4 pi minus 3 pi equals pi. So pi over 12 is 4 pi over 12 minus 3 pi over 12, which is this fraction reduces to pi over 3. Right? 4/12 is 1/3. And then 3/12 is 1/4. So that's minus pi over 4. So now my sine of pi over 12 is the sine of pi over 3 minus the pi over 4, which is the sine of pi over 3 cosine pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. Cosine and sine of pi over 4 are the same numbers. Is the square root of 2 over 2. The sine of pi over 3 is the square root of 2. Square root of 3 over 2. And the cosine of pi over 3 is 1/2. Okay. Is looking at the unit circle. That's this angle up here. And the x value is 1/2. The y value is the square root of 3 over 2. The x value is the cosine, which is 1/2. And the y value is the sine, which is square root of 3 over 2. So now we have the square root of 6 over 4 minus the square root of 2 over, this looks awfully familiar, doesn't it? So it's the square root of 6 minus the square root of 2 divided by 4. And they're going to write it as 1/4 times the square root of 6 minus the square root of 2. And I'm going to erase all this because they're just going to do it only without this explanation to get here. So they rewrote pi over 12 as 4 pi over 12 minus 3 pi. Oh, they did it different. Yeah. 3 and 2 are factors of 12. That means subtract equal ones. Well, let's see how that works. So you have 4 over pi minus pi over 6. So you have the sine of pi over 4. Is it going to be different than what I got? Times the cosine of pi over 6. Minus the cosine of pi over 4 times the sine of pi over 6. No, you can get the same thing I did. It's just these two are reversed and these two are reversed. So it didn't matter how you got 1 pi over 12. Doesn't matter how you get the 1 up here. It'd be 4 minus 3 or 3 minus 2. It's still going to get the same. same result. All right, that comes back, the process is the same, but the details were different. We still get the same answer. And again, I'd write it as a single fraction, not as a fraction. Okay, so 75. So I'm gonna rewrite these. It's gonna be a hell of a mess. Okay, so I'm gonna rewrite these as alpha being 75 and beta being 15. So I can see, does it? So because it fits the pattern for sine, right? For the sine of the sum of two angles, because it's plus between sine times cosine plus cosine times sine of the same two angles. So I'm going to add 75 and 15, and it's going to be the sine of, what is that? What does that give us? The sine of 90? What's the sine of 90? What's the sine of 90? Sine of pi over 2? Anybody tell me? It's the y value. That's the x value. So cosine would have been 0. You missed the drama. The computer did what it did to me last Wednesday. It did a restart. Oh. Okay. And sine of A equals 1 over the square root of 2, which is the square root of 2 over 2. So that means alpha is between, with alpha being between pi over 2 and pi. So that's the third quadrant. Right, so they're talking over here. And sine of beta equals 1/3 with beta being in this quadrant down here. So alpha is up here and beta is down here. Is that a negative 1/3? I can't see that minus sign. And boy, y'all really can't see it. Let me pull it this way. Oops, not that way, this way. Yeah, that's a negative 1/3. So what they have here is the sine of beta equals a negative 1/3. So the square root is 2 over 2 in this quadrant. Well, that's a 45-degree angle. That's going to be what, 3 pi over 4? So alpha equals 3 pi over 4. And the cosine of 3 pi over 4 is negative. And it's negative square root of 2 over 2. Because at the 45-degree angles, the sine and cosine is gonna be the same, it's just the signs may be different. And in this case, in this quadrant, the sine and cosine of that angle are different. Now, over here, we're talking about that sine is 1/3. So that's the y value being divided by -1/3 divided by the radius. So a -1, which is this direction, and 3, which is this way. So this is 3, this is 1. And the x value is also going to be negative. And this is 1 squared plus 3 squared, which is 10. So this is going to be the square root of 10 using Pythagorean theorem. I don't need to know what the angle is. All I need to know is this part here. So now this angle, the sine of that angle, and that's beta, the sine of beta equals a -1/3. So the cosine of beta is going to equal a negative square root of 10/3. So 3 squared plus 1 squared is 10.
Would be the square root of 8.
Subtracting. Thank you. I added. Supposed to subtract, so that's going to be square root of 8, which is 2 times the square root of 2. So this is 2 times the square root of 2/3. Thank you. I was adding them, I should have subtracted the square root. So now I can find, well, I found cosine of beta. And the cosine of alpha is the sine of alpha, but it's going to be negative in this quadrant. Because alpha is 3π/4. And so we found this one, which was what? Negative 2 times the square root of 2 divided by 3. And cosine alpha beta, we use the cosine of alpha times the cosine of beta. Since we're adding two angles, we're going to subtract the product sine of alpha. Right, the alpha sine of beta, and this is adding, so this is going to be the sine of alpha cosine of beta plus the cosine of alpha times the sine of beta. And so now I just plug the numbers in appropriately. Okay. The sine of alpha is the square root of 2 over, the cosine of alpha is a negative square root of 2/2. The cosine of beta is the negative 2 square roots of 3/2. Got the 2 and the 3 squared there. 2 times the square root of 2/3. And it's going to be minus the sine of alpha, which is the square root of 2/2, times the sine of beta, which we got over here, which is a -1/3. Oh, yeah, they told us what it was. That's a -1/3. And here the sine of alpha is what? The square root of 2 over 2. And the cosine of beta is a negative 2 square root of 2 over 3. Plus the cosine of alpha is a negative square root of 2 over 2 times the sine of beta, which is a negative 1/3. Now we just do the multiplies. Square root of 2 times square root of 2 is 2. And negative times negative is positive, so we have 2 times 2, which is, well, I'm gonna write it as 2 times 2 over 2 times 3, so those go away because they equal 1, minus, well, negative times minus makes this plus, and that's going to be the square root of 2 over 6. So, well, since I'm going to get a denominator of 6 over here, I'm not going to do this because I'm going to write it as a single fraction. So this is going to be give me 4 over 6 plus the square root of 2 over 6, which is 4 plus the square root of 2 over 6. So I just wrote this as 4 over 6. 2 times 3, and then the negative times negative make this positive, and 2 times the square root of 2 is 2, so it becomes 2 times 2 up here. Which gives us this out. And we'll see how I fare according to what they do. Okay, and so we're going to get the same number here, but it's going to be negative. It's going to be negative because negative times positive is negative, so it's going to be negative 4 over 6. Because otherwise, all the multiplying is going to be the same. It's just we're going to keep the negative. And I left it with the 6 in the denominator and didn't reduce it because this is going to have a 6 in the denominator. This is negative times negative is positive, so it's 2 times 1. So it's plus the square root of 2. Square root of 2 times 1 is square root of 2, and 2 times 3. So that's going to give me a negative 4 plus the square root of 2 over 6, or the square root of 2 minus 4 over 6. Either way is acceptable. Most people leave it this way, but I would end up writing it this way simply because I like my leading term to be positive. So hopefully they say it's the same as what I do. Yeah, so they did the same thing up here. I did down here. And they got 1 squared plus 1 squared is 2, and so this side is the square root of 2. Or the square root of 2 squared is 2 minus the square of 1, which is 1. So 2 minus 1 is 1, and the square root of 1 is 1. So that's how they got the 1 here. But it's going to be negative 1. And then they get those angles. I just recognize that square root of 2 over 2 is a 45-degree angle. So it's either here, or here, or here, but it's, we already determined that it was in this place, so that's So that's, sine is positive and cosine is negative. And 45-degree angles are square root of 2 over 2, square root of 2 over 2, with the appropriate signs for the quadrants. Erase this, because it's all in the way. And cosine is zero, so they got this same thing. We did negative square root of 2. Alternatively, we can use the same thing in Pythagorean theorem to find cosine. Trig identity. And then for sine of theta, and I use the same thing there they used here to find out for beta. Notice we didn't find out what the angle was. We're just finding out sine and cosine of that angle. So cosine has to be negative. Well, the sine is negative, so it's going down. And the cosine has to be negative in this quadrant. So we find A the same way we did, only they subtracted correctly. Step back. All right, square root of 8. That's a good one to have in your head. 8 is the square root of 8 is 2 square roots of 2. And they do the negative square root because of the quadrant for it. So cosine is the negative 1 over 3. Or no, the negative square root of 2, negative 2 square roots of 2 over 3, sorry. Or again, you could use Pythagorean theorem here to find it. Get the same result. A lot of times that's what I do. I use Pythagorean theorem. But, and so we found part A and B, so we could do this, the cosine. The sum, the cosine of the sum, and you plug those in. And you got, yeah, I think that's what I have, right? 4 plus the square root of 2 over 6. And then use the sum formula for sine, for finding the sines of adding those two angles. And again, they got the same thing, and they wrote it the same way I did. I don't know if you get something that has like the way I solved it, we wound up with negative 4 minus the square root of 2 over 6 plus. I'm sorry, that was a plus there. If you type it in this way and it says it's wrong, go ahead and switch the order where it's going to be a positive minus. Because it just may be this answer selection is not in their answer bit. So if you type it in, it doesn't recognize it. Which is one of the downsides of those programs. I have a super long extension cord for USB. It's a heavy duty cord, so there's the signal loss is small. Right. Establish the identity that is true.
Well, I use the cosine difference formula for the numerator. Cosine of alpha minus beta is the cosine of alpha, cosine of beta, plus, because it's minus here, it's plus over here, sine alpha, sine beta. And I'm gonna write this as two separate fractions. So I have cosine alpha, sine, cosine beta over sine alpha, sine beta. And then I have sine alpha, sine beta over sine alpha. Well, this is just one. And I can separate these out as two fractions being multiplied. I have cosine alpha over sine alpha. Well, cosine over sine, that's tangent, cotangent. Cosine beta over sine beta, well, that's cotangent. So I have cotangent alpha times cotangent beta plus 1. And then they went and wrote it as two separate fractions. You can do that. You can factor out two fractions with a product. And so that's how I got that. The sum and difference formulas for tangent look exactly the same, or look very closely the same. The only difference is where the minus and plus are. If you're adding the two angles, the adding is in the numerator and the subtracting is in the denominator. If you're subtracting the two angles, the subtraction is in the numerator. So whatever the sign is between the two angles, that's the numerator, and the opposite sign is in the denominator. Then the rest of it is just remembering that you're adding the tangents of the two angles over 1 plus or minus the product of the tangent of the two angles. So the formulas that what goes in the numerator and what goes in the denominator is going to be the same, except for where the plus or minus is. So just remembering which one that the sign in the tangent has to be in the numerator, and the other sign is in the denominator. Okay, next thing. Yeah, tangent has a period of pi. So every pi, it repeats. So from 0 to pi, all the tangents of those angles repeat when you add pi. Easier to see on. So if this is theta, then if I add pi to it, it comes down to here. Well, these two angles have the exact same reference angle. The tangent is positive up here and tangent is positive down here. If the angle comes over to this quadrant, then if I add pi to it, that brings us down to here. And these two are going to have the exact same sign. So that's how that works. Yeah, but they want to establish it. Okay.
So the tangent of the sum of the angles is the sum of the tangent of the two angles divided by 1 minus times the product of the tangent of the two angles. What do we do next? Tangent of pi. What's tangent of pi? Tangent of pi. The x value is -1, the y value is 0. That's 0 over -1, which is 0. Someone on the test said it was undefined. No, dividing into 0 is 0. Dividing by 0 is undefined. Okay. So in the numerator, we just have tangent. In the denominator, we have tangent times 0, which is 0. So that's 1 minus 0, which is just 1. So you just have tangent divided by 1. So there we have it. We established that identity. No, I can't affect the angle of the, well, because I don't even know if I have the remote. to it. Nope, that's Epson, this is not Epson control. Is this it? Nope, and because there's no remote in here. Yeah, the remote to the. That's a big one. The remote to the, yeah, I always wanted to do that. I wanted to bring it down just a little bit. So the bottom here is at the tray or below. And so you get more of the screen up here. But and yes, I could do it with the buttons on the machine, but I have to do that later. All right, but yeah. No, I can't. It's ceiling mounted. So I can't. The only way to affect that is to. And what happens? Did it overheat? Oh, I know what happened. I have the button here. I hit that button. Okay. Oh. I need to reposition this now. Yeah, if I could raise this thing up. I went through a couple of slides. This would say. Okay, now beta plus half pi is cotangent. Yeah, because cotangent and theta are and cotangent and tangent are a period shift of pi over 2, just like sine and cosine are. And secant and cosecant. Those pairs are just phase shift off of each other. But with tangent, it's going, and cotangent, they're going to be negative of each other. So the tangent of 45 degrees and the cotangent of what would that be? 5 pi over 4. They're going to have same different signs. Half a pi. Okay. Yeah. So 45 degrees and 135 degrees are 2 pi. I mean half a pi difference. So pi over 4 versus 3 pi over 4. They're a half a pi difference. And they're in these two quadrants here. Here, tangent is positive and cotangent over here is negative. But they're going to have the same numbers, it's just opposite signs. And so we're going to do the addition thing. Well, okay. Writing tangent as sine over cosine. And we do the plus angle. And for both of these. So we get sine of theta plus cosine times cosine of 1/2 and cosine times sine of pi over 2. Well, sine of pi over 2 is 1. Cosine of pi over 2 is 0. So this one's going to go away. And so this is just going to be, the numerator is just going to become cosine theta. And again, cosine of pi over 2 is 0. So this is going to go away. So we're just left with the negative sine theta. And because sine of pi over 2 is 1, so we're just going to have cosine theta over negative sine theta. Okay, so these two terms go to 0, and these two terms just cosine and sine of theta. And migrating the negative sign out front, cosine over sine is cotangent, so that's just negative cotangent theta. And there we've established that identity. In my finger. I always have to say that at home because my wife says, take your finger out of it. It's no joke. Time wise, we're gonna stop here. 339, slide 339. Someone write that down for tomorrow. Okay, so come on, there we go. Unless y'all have questions for me, y'all are free to go. Don't forget to sign in before you leave. And I grade them, and I make notes on them. And there's supposed to be a way for me to download them and upload them back again so you can see on my notes. But okay. And but there is a way I can download them, but I have to change the title. Because it won't, because when I re-upload them, they won't, it'll say, I don't know where this belongs. Because the title's wrong. Okay. So whatever the title is on yours, it has to be the same so I can re-upload. Okay. So it'll just have all my notes on it. So that's gonna take a little bit. So what I'm gonna do is just go ahead and post the grades. Okay. Sounds good. I was just curious. I looked back and it's just gonna have like yeah, you check the notes here. Because there's, what's the 30 from?
Well, because there were some answers that I could answer in the thing, so I guess I got to wonder if some of those right.
Oh, you're talking about in my map?
No, and so like, when I took the exam, I had to fill in the answers, and then you were gonna go back and fix them all.
No, how I'm gonna fix them is on the text.
Okay, just all, I think, right?
Yeah. So I don't need, say, I don't need. I just look on the final.
That's what I was thinking, I was like, can I just say answer on paper for every answer and? So I have one more question, is there a deadline on like the homework? Homeworks, I got a bit behind on them. Deadline it all says like December 10th.
Yeah, for exam one, because we had so much problems, and so much shit going on. I'm not gonna hold to a deadline. So I'll end up putting a deadline on it, but I'll still pull the grades and whenever you get those done, they'll still put the grade, even though I may post one grade and then with those boosted up even more, I'll change the grade.
Okay. Yeah, 'cause
I have to have them.
I'm gonna have a lot more time these next 2 weeks, and I'm gonna try to catch everything.